We've seen this problem now in one dimension, so let's see what it looks like in two dimensions. Um, what I have here is, I like to do this in terms of things like population or the total amount of real estate in a town because we're talking about a region that has an area when we do this. So in this problem, Trapezoidville is located next to an Ebola virus research facility, but since no one wants to be near the Ebola virus, the population density of the town is 14,000 times x to the 3 halves people per square mile. Let's keep in mind that unit here, at a distance of x miles east of the Ebola facility. We're asked how many people live more than 1 mile east of the Ebola facility. Um, so, first of all, I've put in here a compass just so nobody gets confused between west and east, so that the entire town lies to the east of the Ebola facility. Now, I realize many of you are probably watching this video in the year 2030, and you don't remember what the year 2020 was like. So, just to understand the context, there was this horrible virus in the White House, and there was also a COVID-19 pandemic at the same time. So nobody really wanted to be near viruses, and that's why everybody stayed away from the Ebola facility, and that's why the density of the population kind of goes up as we get further away from the left side of town. That's what this density expression, this density function indicates. So the way you want to solve this problem is, let's draw in one thin rectangle, and you can probably see maybe where I'm going with this. What's the width of a thin rectangle in calculus? It's dx. And what's tight? Well, the function y equals 1 half x plus 1 tells us that at a distance that is x miles east of the Ebola facility, the height of that rectangle is going to be 1 half x plus 1. So we can say the area of one rectangle is equal to 1 half x plus 1 dx. Now, we're not really interested in the area. We'd know how to form this integral easily if we were interested in the area and adding up the area of the town. We want to know is what the population of the town is. So the question is, how many people live in that thin rectangle? Well, the number of people in the thin rectangle equals its area, which is measured in square miles, times its density, which is measured in people per square mile. Again, the units come out right. We're looking for a number of people in that rectangle. We can get it by multiplying square miles by people divided by square miles. So that's going to be the area of the rectangle, which is 1 half x plus 1 dx, times, we have the number of people, per square mile, and that's going to be, this is the number of people in one thin rectangle. So how do we find the total number of people in the given region of the town? Oh, by the way, I just wanted to point out something. This function here, the density function, is often called rho of x. That's not a p, that's not an e, that's the Greek letter rho, which is like an r that's used for density in chemistry and apparently in math too. So we often call that rho of x. Let's just put it in, rho of x, spelled RHO. Okay, so how do we do this? Well, what we're going to do is we're simply going to add up all the people in all the thin rectangles. So I'm just going to write this expression. I'm going to rearrange it so it looks like calculus. We're going to write 14,000 times x to the 3 halves, 1 half x plus 1 dx. That's not really different from what I wrote here. It's just that we know that it always ends with dx, so I'm just putting the constants first. And we know that we're interested in people living 1 mile east of the Ebola facility. So we're not really interested in the people who are living there. We're only interested in the people living east of that first region. It's not that nobody lives there. It's just that the problem asks for people east of that. So we're going to go from 1, that's the lowest possible distance in the question, all the way up to the end of the town, which is 4 miles east of the Ebola facility. So with that setup, all I'm going to do is zip through the algebra, and we will get the total number of people living in the town. So there we go. That's the population of Trapezoidville, at least 1 mile east of its western border. So it's 427,600.